everyone, happy Thursday. I'm Nidhi. Oh,
I'm Dylan Heslop.
I'm Juliet.
and this summer we're working with Grace to build CineSage, the sage for all your cinema problems. We're building a searchable memory pipeline for long-form videos. But first, why? 24 hours a day, 7 days a week. Cities are constantly producing data, but with all that data, it's hard to search, summarize, and reason over manually. So it's only natural to ask the question, what if cities could tell us stories? Let's take a look at the example on the right side of your screens. Here we can see a pedestrian, let's say someone named Jason, crossing the street at a shortcut that probably isn't supposed to be there. Not only is this extremely unsafe for Jason, completely random name by the way, but also it's unsafe for incoming traffic. But our security camera here captures that footage and hopefully builds a smart informed decision that allows it to design, CAD, and implement safer changes for smarter cities. But to get to that dream world, we need to answer 3 questions at scale, time, and bias. First, cities generate large amounts of video, but most of it is hard to search manually. Second, current VLMs are great with short clips, but struggle with long videos. And third, many systems give answers without showing exact evidence, leading to hallucinations. So to solve these problems, let's take the application of city footage and this summer work on our CineSage movie testbed to build and evaluate CineSage as a configurable, searchable memory system for video.
Over the course of the summer, we have tested dozens and dozens of different models, and we have decided to go with a couple of these for their accuracy.
Awesome. Let's break down the whole pipeline by 5 steps, starting with process layers, retrieval, building context, LLM answering, and finally, the user demo. On the right side of your screen, you can see the full pipeline from start to finish, movie clip to AI answer. And we'll start by talking to you about the processing layers.
So here begins the first step of our pipeline, where the movie memory is actually generated. We separate our movie memory into 6 main layers, including frame visual, frame caption, the object layer, our localized memory layer, our tracking layer, and our transcription layer. And now we're going to quickly look through how these layers look like with a scene from the Hunger Games. So here we have our frame visual and frame caption layer. First, we extract the frames and timestamps from the video, shown here at the 16-minute mark. Then we give each frame a unique identifier that other layers can reference to. Each frame's visual representation is then stored as part of our frame visual layer. For our frame capturing layer, we give each frame a generated description using Florence and Quen VLM. And here you can see that the caption is showing the 3 people present in the scene. And now we have our object layer, where we use YOLO to detect important objects in the scene, such as people, objects, or other scene elements. Now, when the localized memory layer is also active, this gives each detected object a more detailed description produced by Florence Large and a describe anything model. For example, what might simply be detected as a brooch from the object layer gives a more specific description about its elegant or purple color. And now here for our tracking layer, we are following people and objects over time in the video clip. How we do this is that we use ByTrack and re-identification. We collect every person's facial and body appearance embedding. And then any similar embeddings that appear over time, we classify that as the same person and give that a global ID. And now we also incorporate audio information through our transcript layer. We use WhisperX to collect character dialogue and Piano to separate character speakers by voice. With this, we can see what characters are saying. In this example, no one is actually speaking, so the transcript layer only detects the music playing in the background. And here you can see a diagram showing our whole layer design pipeline. After all the layers are generated, they get embedded into our database using CLIP for visual embeddings and BGE for our text embeddings.
And now onto the retrieval part. After we get the metadata, it gets stored in the QDrint database. The evidence inside of it gets re-ranked depending on the user's query, and the top 5 ranked evidences get sent to Quen to use to respond.
And for the next part of our pipeline, we have build context and LLM answering. So first, we have our context builder, and the main purpose of our context builder is to pass evidence and prompt to the LLM. The prompt that we pass is a system prompt, which gives instruction to our Quen reasoning model to only use evidence that is internally provided by the database. And this makes sure that it doesn't cheat by using any publicly available data, in this example about our movie Hunger Games. And then we'll go on to our user demo. So here, our demo was built with vanilla JS on the front end and a fast API backend using Python. And on the front end, the user will enter a user question, their question, and a video ID, and that will be passed into our backend API where it will do steps 2 to 4, and it will do the DB search, retrieval logic, and it will give us the answer and evidence that will be presented on the front end.
Here you can see our whole pipeline from start to finish.
And now we have ablation testing. As we discussed before, our memory layers are configurable. We can switch them on and off to control what evidence our answering model sees. So this allows us to identify what types of layers contribute the most to response accuracy.
And so far, we have ingested 2 films, which are Automat, which is a 50-minute film, and it was processed at 2 frames per second. And next, we did Hunger Games, which was processed at 12 frames per second.
Of course, no good system is complete without its evaluation metrics, so here's ours. Unfortunately, it does look like it was cut off a little bit, but there are 8 scoring categories from answer correctness to temporal grounding. Every single category is evaluated independently from a scale of 0 to 100. It's important to have different categories because just because an answer is accurate doesn't mean it's the most precise answer that a system can give. For example, today, a system could describe I'm wearing a white shirt, but that's not as accurate as I'm wearing a white collar button-down shirt. And that's the point of our evaluation pipeline. Here, those evaluation metrics are provided by sample questions in 9 different categories. Some of those categories include localized detail, asking questions like, during Effie Trinket's first appearance at the reaping, what type of outfit was she wearing? To different categories for different categories of understanding. Of the 9 categories, we can try and understand how to evaluate the system better.
Afterwards, we grabbed a handful of questions from the bank and created golden standard answers. We then provided those answers to the judges that we have, which are Prometheus, Judge LM, and Flo LM. We then asked Quen the same questions and saved those answers, gave them to the same judges so that the judges can do a 1-to-1 comparison, giving us these scores. We used 3 judges to eliminate the bias. Prometheus is always the stricter judge, while Judge LM seems to be more forgiving for questions such as the Mockingjay pin, seen before the reaping appears, again later, where does it appear? Reappear, sorry. And these are the scores that we get. These are some of the results of our evaluation questions so far. These are the averages of all of the judges and the average of all of the judges' averages.
So here we're going to go through what ablation score looks like. We'll cover one question here. When Katniss is in the woods, what is she wearing? And so first we'll look at what the setup looks like with the full memory. We can see here that we get an accuracy of up to 80%. However, we'll see what happens when we turn off our frame caption layer or even our object layer. What you see here is that there is a stark decrease in accuracy. Even for Flo LM, which is pretty forgiving, that drops to 60%, showing that for this scene about localized detail, it's important that we see not only the general caption of the scene, but also details about the specific person.
Awesome, now it's time to go on to our video demo. First, we'll start by describing the interface that we use.
All right, so here we have our user interface, and this is the home page where you will see the different videos that you can select. And next, when you select a video, you'll see up here, you'll see the status where you have the different dependencies of our system, which is the backend, the Fusion database, and Coin. And also, if any of these turn red, you can just please contact the team at jalstrom@fau.edu. And then we also have our modalities, which is visual and audio evidence. And as you can see, when you toggle on these, they also toggle off corresponding layers as well. And we also have quick action buttons such as enable and disable all. Next, we have the video evidence player, which gives you like the video that you're asking questions about. And like when you see the evidence, you can click it and it will actually fast forward to the exact clip or scene where it gets the evidence from. And finally, at the bottom, we have our prompt where you'll enter your question and it's sent.
Now that Dylan has talked you through the interface, let's get to the good stuff. Let's ask a question to the system. Here's what query and evidence looks like for inside the Hunger Games pipeline. Of course, you can see that all of the ablation layers are turned on, and we're asking a pretty simple question. If you know the movie Hunger Games, what is the reaping day? But to a regular person, that seems like an odd question. Here's what it looks like when you let the model process. First, it gives you an answer of what the reaping day is, a 5-sentence answer talking to you about details in the movie, along with details like who the people of Pan Am are, why they do this tradition. The novel part of this pipeline is what's below, the View Evidence button. Here we can see visual evidence that contributes to the model's answer. For example, at 21 minutes and 6 seconds, there's evidence that specifically contributes to the answer on screen. Additionally, if you scroll a little bit further down, you can jump to specific parts in the video that proves evidence. So once again, it tries to lower the percentage of hallucinations that are there. And on screen, you can see the video playing that answers the question about what is the reaping day.
So now we'll go over what the ablation test looks like. So here you can see we toggle off our audio or transcript layer, and we're going to ask the same question. What is reaping day? And what you'll eventually see here is that the model says, hey, I don't have enough evidence to answer this. That's because it's missing the information from some important scene where they are explaining the history and tradition of the Hunger Games. This shows that our system doesn't just answer, it answers with evidence that's available.
And lastly, the judge evaluation pipeline. This happens in the back. You can ask the same question you would ask in the front end. Quen would give you an answer. That answer would be then saved. And while you're waiting, the judges are scoring the answer, and you are able to see the answer in the terminal afterwards. Yeah.
Now that we've described to you what our pipeline looks like on movies, of course, the application to projects like this one are for smarter cities. So rather than asking questions like, when does the conflict begin? We can ask questions like, did pedestrians use the designated sidewalk? Which helps city planning efforts across smarter cities in America. We'd like to thank CS3, NSF, and iSense, along with our mentor, Dr. Hallstrom, and the amazing REU crew this summer for an awesome time. And thank you for listening to CineSage, the sage to all of your cinema problems.